Hey everybody, this is Larry. This is me going with Q3 of the weekly contest for 30 count special subsequences. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one I saw, only 266 people got this one, which is even fewer than Q4, though Q4 is a little bit of a, I wouldn't say easy, but just very specific thing that is easy to implement. But in any case, yeah. The idea here for me is just kind of, well, there are a couple of components, right? One is kind of to do the math and maybe use a little bit spoilery. But yeah, basically you have this formula, and this formula is a little bit awkward because we have this condition, right? So the first thing I wanted to do is just be able to divide it into these two things, right? So that it's just easier to, for me in my mind anyway, to at least explore. Maybe even necessarily with anything, but yeah. So then now to put them on one side, then now we have is divided by num sub q is equal to num sub s divided by num sub r, right? And this is straightforward, hopefully, in that we just divide num sub r on both sides, and we also divide num sub q on both sides. So then now we have this relationship, right, on two different places. And the reason why I wanted to do this, and I think there are different ways to handle it, for sure, but the idea is just that we can pre-process them separately and then kind of do a sliding window kind of thing, right? And yeah, and there are a couple of caveats. First is that you can keep them in fraction. I don't know if that works. Maybe that works. I think someone told me that for less than 1,000 in theory you shouldn't deal with rounding things, but still I would not trust it. So what I would do is just use a fraction, right? And there are a number of ways to do a fraction for precision. I'll show you my way in a second. But yeah, but I just actually keep it pretty straightforward. It's just two numbers, numerator, denominator, and we reduce it if necessary, right? That's it. So I think that part, I think it's easy to think of and do once you've done it a few times, at the very least. If not, maybe that's the thing. I'm not gonna lie, I got this kind of okay, so I don't know necessarily the difficult parts that people are finding in this problem. So definitely leave a comment and maybe I could address them, or like get them into my head or something. But yeah, the other thing is that the way that I wrote this maybe is a little bit awkward, but the idea should be, pretty okay, which is that the idea of sliding window. And I'm kind of bringing up the drawing thing. But the idea of sliding window is just, let's say you have the entire, I cannot draw straight lines. But let's say this is the array, right? Okay, straight enough. The idea with I said sliding window, sorry. I lied. I meant sweep lines, or line sweep, right? And what I mean by that is that, okay, so, we have a, okay, let's see. Let's change the color real quick. So we have a line that goes from left to right, or it doesn't matter if it's right to left or whatever. But then now we want to say we have, which one is it? P and Q. We have P and Q on this side, and the process P and Q, and then the process R and S on this side, right? And as we go from left to right, then now we remove pairs that are possible, right? Or fractions that are possible. And here maybe I could rewrite this as, so maybe on the left side, red is kind of ugly. Maybe on the left side we have, let's just say A for, I know that's nums for whatever, A sub P over some A sub Q, right? So now we just kind of process all pairs on the left side, and then but we can also reprocess this on the left side, on the right side, so that when we sliding window, we remove things that are based on R, right? I think R is the less than S, right? So as we go from left to right, numbers just drop off, right? So maybe here we have, I don't know, just made up numbers like 1 over 2, but if we go to the left, we just subtract them. So that's really the idea behind the sliding window. I keep saying slider window, my apologies. I mean sweep line algorithm, right? And yeah, I don't know why I keep saying slider window, but yeah, so that's basically the idea. And as you can see, I actually did this, and you can feel free to watch it live, but yeah, this is the recurrence that we not recurrence, but formulation that we had, right? I mean, straightforward so far. Here I put all the events because I think of sweep line as just events and them happening. So I put the events in a dictionary on a list. We'll talk about, we'll see that in a second. And then every is just every pair that exists, right? Or every fraction maybe, right? So these are sweep line events. We'll talk about that in a second, but these are every fraction that exists on the right side. And then now here we just process every SR pair, and we process that in a way that, of course, S or R is less than S, and not only that is we have at least one space in between, right? I mean, this part you can do the math on the for loops, right? This is just n squared. Hopefully straightforward. This is the fraction part, right? This is the top of the fraction. This is the bottom. Hopefully this is understandable. We just have a GCD to calculate the greatest common denominator, or the greatest common factor, and then we divide them to get a reduced fraction, right? So this is reduced or simple fraction, maybe, I don't know, reduced, simple, whatever. And then for every fraction that exists, we add 1, and then we want to add R because R is the event in which we remove an item, right? And then we want to append key to the fraction to it, and that's it. And then now we want to process every what's it, Q and P and Q pair. I wrote this in this way just because we want Q to be, Q is the number that's bigger than P, so we sweep it as we go to Q so that we can kind of maintain the invariant. And here this is, you know, removing the process events to remove Q and Q plus 1 from remove the fractions that contains Q and Q plus 1. I just, at this point, maybe it's a little bit, you know, the Q and Q plus 1, keeping in mind that as you sweep, you're only removing Q plus 1, so you only do Q once, but it doesn't, even if it doesn't, it's fine. You're only doing everything twice. It's a little bit slower, it's fine, right? Yeah, so then for every event, every key, which is a fraction, we just subtract by 1, and then we set it to empty so we don't do it again in the future, both for the time reasons, because then now in the future this is a little bit cheaper, but also for this reason of, well, you don't double removal, right? So yeah, so that's basically the idea. Process events to remove fractions as you sweep from left to right. And then here we just brute force the P to process, and we get the fraction, and then we just add up the sum, and that's pretty much it. This is going to be n squared, assuming that map looks up a linear, or sorry, constant. So yeah, this is n squared. This is n squared as we process, right? I know this loop looks a little bit awkward, but there can only be n squared events, so everything summation removal is going to be n squared. You know, you could say amortized. So yeah, this is also n squared. So in total, this is an n squared algorithm, and that's pretty much it. Let me know what you think. I'm making it a little small so you could see the entire. Okay, yeah, you can see the entire thing on screen. And yeah, I would like to think this was, you know, like I didn't. Sometimes, not, you know, when I'm doing these videos, I try to think about where people are getting it wrong. And I'm not quite sure for this one, so definitely let me know in the comments. What did you struggle with? Is it the fractions? Is it the sweep line or whatever? But yeah, let me know. Thanks for watching. And you can watch me solve it live next. I kind of play around with some of these ideas, so that may be interesting. But yeah, thanks. 2 wrong answers. This is a terrible start. Okay. Or 3 wrong answers in total already. But okay, we could catch up. There's only, I mean, we're cheating in that we know that only 366 people finished this. But more people finished Q4, huh? It's a weird one, for sure. No, they don't, even on the virtual contest, they don't give us the rankings, even though they give us this, so it's already weird. Okay. Anyway, let's actually solve, hopefully. A subsequence of length 4. Num sub p, one element between each pair of indexes. What's a different subsequence? They definitely define what a different subsequence is. And what I mean is just that, like, different can mean a number of different things. Is it like the PQRS that's different, or the num sub, you know, whatever is different? But I don't know. Anyway, okay, focus. PRQS. That's such a weird way of looping this index. Okay. So there are always at least one, right? Thousands interesting. That means that we can probably pre-calculate things up to 1 million. There's some trivially true things here, but I mean, n square is fast enough. So we just have to loop the n square in a not dumb way. I mean, we can rewrite this, right? To wait, Q, right? So that's just Is that better? I don't know. It's definitely awkward. So then you're going from left going to right. Okay, fine. Yeah, I think that's a little bit better. You could just store this as a fraction. It's only 1,000 over 1,000 things, so there's only, so that's actually not that bad. Okay. How do we want to write this? Okay, let's just say if, for example, if we had, I don't know. Then now you have nums of p over nums of q, right? Maybe a pair, and we want the GCD of them, right? So then now we have this as the thing, and then q is the dividing thing. And then maybe you can do a lookup. Can you do a lookup? Yeah, that's not so bad. It's just really annoying to do. Okay, fine. Maybe you could do some backwards. All right. So then now we do the same thing, right? And then now we want to say at R there's an event, right? So maybe we have event is equal to, no, we want okay, right? So something like that. Yeah. I mean, it's annoying to do, but I think I'm doing it. I'm just trying to trying to do it not in a dumb way, but maybe that's not possible. But okay. Well then, yeah. No, the way that you have to think about the loop a little bit differently. You can't just do the loop this way. Oh yeah, okay, that's fine. Yeah. I'm just writing this loop dumbly. Okay, so then let's write this loop in for q in range to n, and then for p in range of whatever, q minus 2, right? Okay, now we're in business. And then now we can say now we can say, and this is maybe q minus 1 actually, honestly. Yeah, okay, but now just say oh yeah, okay, fine. Every and then now I've total 0 0, right? So then now for every time we process a queue, then we want to say for all in events sub, we want to say queue is no good. Yeah, we want to create queue and queue plus 1, right? Okay. Maybe something like that. You can even just write it's a little bit awkward, but it's fine. Okay, and then now we can just do something like that should be fine, right? 22. Okay, well that is way not what I expected. Okay, so let's see if I'm right on, or even remotely close. Of all these things, right? Probably. I mean, I think the idea is right. I just have to debug it, I suppose. Yeah, this is, I want to debug with a smaller thing, but that's fine. Okay. Maybe print all. Oh. Okay, so oh, is the row? Okay, what? What was it before? Okay, 3 1. Okay, oh 1 1 4 1 3 1 2 1 1. Okay. Okay. 2 3. That's probably right. Wait, what? No, 4 6 4. Yeah, okay, that's actually right. Okay, I forgot they had to skip by 2. 6 3. Okay, so this seems right, right? So then why is this part wrong? Okay, 1, 3. You have 2 things. 3, 1. And that's it, right? Why would there be 2 things? Oh, this is silly, that's why. Because I didn't properly remove this. Oh, Larry. 1 and 3. Okay, that's good. Yeah, okay. Now that you so many silly mistakes. Alright, give it submit. Hopefully it doesn't time out. Okay, that wasn't that bad. I don't know. I don't know why. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest or this virtual contest, this explanation, the problem, everything being trained. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.